In this lesson, we're going to focus on equations of lines that are parallel or perpendicular. Now, parallel lines are lines that have the same inclination. And because they have the same inclination or slant, the slopes are equal. In your toolbox, parallel lines, m1, which is the slope of the first line, is equal to m2, which is the slope of the second line. All right, perpendicular lines are lines that intersect each other at right angles. So if one of them looks like this, the other one will look like this, and all of the angles in the intersection are right angles. Perpendicular lines, the slopes are two things: opposite in sign in other words, if one of them has a positive slope, then the other one has a negative slope. They are also reciprocals of each other. If one of them is 2 over 3, the other is 3 over 2, but with an opposite sign. So, just as an example, parallel lines might be y is equal to 3x plus 4 and y is equal to 3x minus 7. Those two lines would be parallel because their slopes are the same. Their inclinations are the same. Perpendicular lines we have y equals, suppose we have y equals negative 2/3 x plus 8, y equals 3/2 x plus 4. Those two lines would be perpendicular because the slopes are opposite in sign and the reciprocals of each other. That's the information we're going to need to use to write equations using parallel and perpendicular information. Because parallel and perpendicular lines can be identified because of their slopes, slope is going to be very important. All right, let's look at this first one. It says write the equation of the line. Write it in standard form, and let's see, we've got, all right, something we have to be very careful about, and this only occurs in a few of the homework problems. It said to write it in standard form. Now, standard form is ax plus by equals c. And the rules are the x and y terms are both on the left. The a needs to be positive, constant over here. You might consider it a little bit of a silly form, but it is what you need to do for a couple of problems. Watch out for the phrasing standard form. Okay, what have we been given? We have been given that it goes through, and I do understand that I'm abbreviating the word through, 3, 3. Now that's a point. That's an x1, y1. It is parallel to 10x minus y equals 3. Now, a key word here is the word parallel. If lines are parallel, they have the same slope. So if I could figure out the slope of this line, I would know the slope of my new mystery line that I'm trying to discover. So let's get this in slope-intercept form. Let's solve it for y. I'm going to subtract 10x from both sides. That gives me negative y is equal to negative 10x plus 3. Divide everything by negative 1. And I have y is equal to negative over negative is positive 10x minus 3. The slope of the given line is 10. If the slope of that line is 10, then the slope of my line is 10 also, because parallel, same slope. All right, so, whoops, give a little more work room. What I can do from that, now I have a point and the slope. So I'm going to use point slope. Remember, what you're given tells you what to use. All right, so y minus y1 is equal to m times x minus x1. Y minus, the y value is 3, is equal to slope. We calculated it to be 10. X minus, the x value is 3. So I had an x1 of 3, a y1 of 3, and a slope of 10. The slope was 10 because the slope of this line was 10, and they were parallel. So now it says don't get it solved for the y equals, instead standard form. So I do a little bit of things different. So I have y minus 3 is equal to, still use the distributive property, 10x minus 30. I need the x and the y on the left, so I'll subtract 10x. So I have negative 10x plus y minus 3 is equal to negative 30. I need to add 3 to both sides. Give myself just a little bit more room. That gives me negative 10x plus y gone is equal to negative 27. And then we have that one last rule about standard form, is that the coefficient of the x term has to be positive. So since it's not, I'll divide everything by negative 1, and I get 10x minus y is 27. This is standard form. X term, y term, equal sign, constant. Coefficient of the x term has to be a positive. So, several things in this. We were told that we had a point, okay, that's an x1, y1, parallel to a given line. Take that line, find out its slope. Because it used the word parallel, that means my slope is the same. Then use point slope, and unfortunately, well, at least my opinion is standard form is a little more awkward. All right, let's work on another one. All right, once again, I want to find the equation of a line that goes through 6, negative 8. All right, that's my point, and it is parallel to 5x plus 7y equals 2. And it says standard form for my answer. They've told me my line is parallel to this one. If I can figure out this one's slope, I have my slope. So I will solve this for y. Subtract 5x. I have 7y is equal to negative 5x plus 2. Divide everything by 7. And I get y is equal to negative 5/7 x plus 2/7. There's the slope of this line. Because the lines are parallel, the slope of my line is also negative 5/7. So, parallel means same slope. All right, let me give myself some room, because now I want to use, I have a point, I have a slope, use point slope. So y minus y1 is equal to m times x minus x1. That's y minus negative 8 is equal to negative 5/7 parentheses x minus 6. All right, I'm going to have to be cautious, a little more careful, because I am dealing with a fractional slope. Minus minus means plus, so I have y plus 8 is equal to negative 5/7 x. Going to multiply here. Go do it in my little cloud. Have negative 5/7 times negative 6/1. Nothing reduces. Negative times negative is, I'm so sorry, is positive 30/7. Positive 30/7 plus 30/7. In standard form, there are not any fractions. So I'm going to multiply everything by 7. That's the LCD, and that will eliminate my fractions. That gives me 7y plus 56 is equal to, these 7's divide out, have negative 5x. These 7's divide out, and I have plus 30. I need to add 5x because in standard form the x and the y are both on the left. That gives me 5x plus 7y, 5x, 7y, different terms, plus a 56, still there, is equal to, those are gone, 30. Subtract 56 from both sides, and we end up with 5x plus 7y is equal to negative 26. That is the standard form of the equation of this line. All right, let's look at a few others. I think the rest of the problems are going to be in function notation. All right, find the equation of the line through 4, 6. That gives me an x1, y1. When it goes through a point, that's a point on the line. And it is parallel to y equals 3x plus 8. Well, this is a really friendly problem because parallel, I need to know the slope of this line, and I can see it. This slope is 3, which means my slope is 3 because parallel means same slope. All right, so we're going to use point slope because we have a point in the slope. Y minus y1 is equal to m times x minus x1. Y minus 6 is equal to 3 times x minus 4. Distributive property. This one I'm getting in function notation. I'm getting y equals distributive property 3x minus 12, add 6, and y is equal to 3x. Negative 12 and positive 6 gives me negative 6. And this right side is all you'll have to type in because it says f of x equals. So that one was quite a bit easier than the previous one. All right, let's look at number 4. Write an equation of a line using function notation. So I'm going to get it in y equals format. It goes through 5, negative 4, and it is perpendicular to 6y equals x minus 12. All right, the word perpendicular, I need to know the slope of this line. Okay, I can do that by solving it for y. So y is equal to, I'm going to write the coefficient of x as the fraction 1/6 x minus 2. 12 divided by 6 is 2. The slope of this line is 1/6. Now, my line is perpendicular, so slopes are opposite and reciprocal. So the slope here has got to be a negative because this one was a positive, and the reciprocal is 6 over 1. I will just write it as 6. So now it's time to use my point slope again. I have point slope. Y minus y1 is equal to m times x minus x1. Y minus negative 4 is equal to negative 6, which is that slope, times x minus 5. That's y plus 4 is equal to negative 6. Negative times negative is plus 30. Subtract 4 from both sides, and y is equal to negative 6x plus 26. And since it is in function notation, it's going to say f of x is equal. You're going to fill in the box with that right side of your equation. All right, we have one more. Oh, we have two more. Didn't realize how much fun we were going to have. All right. Goes through negative 5, negative 7, and it is parallel to, oh, that's a mess, sorry, parallel to 3x plus 5y equals 8. If two lines are parallel, they have the same slope. So if I know the slope of this line, I will know the slope of my line. We need to get it in y equals format. Subtract 3x. I have 5y is equal to negative 3x plus 8. Divide by 5. And I have y is equal to negative 3/5 x plus 8/5. There's the slope of that line. Because they are parallel, that's the slope of my line. So I have a point, I have the slope, point slope. Y minus y1 is equal to m times x minus x1. That's going to be y minus negative 7 is equal to negative 3/5 times x minus negative 5. That's going to be y plus 7 is equal to negative 3/5 times x plus 5. Use the distributive property. Y plus 7 is equal to negative 3/5 x minus, all right, I need to multiply, negative 3/5 times 5 over 1. The 5's divide out, and I get minus 3. Subtract 7 from both sides, and I end up with y is equal to negative 3/5 x minus 10. And double check, it does say to write it in function notation. All right, now I have one more problem. This line goes through negative 14, 11, and it is perpendicular to y equals 7. All right, this one is a little bit different. Perpendicular to this. Now this is what I consider one of my special lines. My special lines are y equals a number and x equals a number. Y equals a number is horizontal, x equals a number is vertical. If this is a horizontal line, then my line is a vertical line because they are perpendicular. If my line is vertical, then it is x equals a number. X equals, well, just grab the x coordinate, negative 14. Now, it does want this in standard form, and this is standard form for a vertical line. So hopefully that is enough. That's quite a few examples for you to find the equation of the line, and each one of these was related to the concept of parallel or perpendicular. Remember that lines are parallel, their slopes are the same. Lines are perpendicular, their slopes are opposite in sign, one positive, one negative, and they are reciprocals of each other. Okay, so please work on that assignment.